Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. In this lecture, we are going to see the basic definitions and terminology that are related to engineering materials. Currently, we are in the third module where we are studying different engineering materials. So, let us see some basic definitions. So, when we are studying engineering materials, there are wide varieties of materials that are available and they can be used for engineering applications. And one of them is metal. We have a broad classification, metals and non-metals. Even in metals, we have other classifications like ferrous and non-ferrous metals. When we see the definition of a metal, metal is a iron containing metals which include all types of iron and steels are called ferrous metals, and the metals which does not contain iron can be called as non-ferrous metals. So all these ferrous and non-ferrous metals comes under the category of metals. So some examples of ferrous metals are example cast iron, wrought iron and steels. And some alloys of these metals are also there. They are silicon steel, high speed steel and spring steel. And then we have non-ferrous metals. Non-ferrous metals, the best example for non-ferrous are copper, aluminum, zinc, lead, etc. So these are the base metals which are non-ferrous also. They have many alloys. By combining with other metals, alloys are formed. They are brass, bronze, duralumin, etc. So when we take the basic definition of metal, a metal is a very strong solid which is made up of closely packed molecules. This can be used to take loads. They can take different types of loads like impact, gradual, and they can be converted into multiple shapes. Yet they can be withstanding loads. We can work on these metals to get required shapes, and we can make alloys from these metals by combining with some other compositions. And the metals are the key things which makes mechanical engineering and manufacturing industry so possible. And then we have non-metals. So the engineering materials which are not metals. So if any material which contains items like ferrous, iron, silicon, copper, aluminum, they all comes under the category of metals. Now, when we see the definition of non-metals, so these are the metals or the materials which does not contain any of the iron, copper, any of the ferrous and non-ferrous metals. Then they can be called as non-metals. So these are the commonly adopted non-metallic materials are leather, rubber, asbestos and plastic. These are dimensionally and structurally weak when compared to metals. When we take the example of a non-metal leather, leather is structurally weaker when compared to a metal, but it has its own properties. It can withstand temperature or it can be used for wearing out processes. And plastics, particularly we take the example of plastic, where it is much weaker than a metal, but plastic can be converted or can be manufactured in different shapes and sizes. So these are some examples of non-metals. They are leather, rubber, plastics, asbestos, carbon, etc. And then leather is used for belt drives and as packing or washers. So these are different applications of leather. It is very flexible and it can take considerable wear under suitable conditions. The modulus of elasticity of this leather varies according to the load. So depending on the load, the modulus of elasticity will change. Whereas for a metal, the modulus of elasticity will not change. It is constant and in any direction, like in all the three-dimensional space, the modulus of elasticity for a metal is constant. And then we have rubber, the second type of non-metal. So it is used for packing and it is also used for the manufacturing of belt drives and it can act as an electric insulator. It has high bulk modulus and must have lateral freedom if used as a packing ring. In the case of IC engines, we use this rubber for packing the internal combustion engine. It can be used for sealing other metallic cylinders kind of things, boilers, etc. In those things, we can use rubber for sealing off. So when we take the example of a boiler, in boiler, the freshly made steam, it has to be collected in the tank. It should not go out into the temperature. For that, we have to make the tank airtight. So tank is generally made up of metal. It does not have that much of airtight capacity. So that is why we should use this rubber as air tightening material. And then asbestos. It is used for lagging around steam pipes and steam boilers. So whenever we have joints that are made up of metal, we have to seal those joints with the help of a material called asbestos. And then we have plastics. So plastics are another very important non-metallic substance which has wide applications in the engineering industry as well as the domestic purpose. So it is a term applied to a large class of moldable organic compounds which are sold under different trade names and are being discovered constantly. See, in the last 2 to 3 decades, the use of plastic has predominantly increased because it has more applications. It is a polymer which is made out of an organic compound. Yet, the new forms of this polymer are being developed every day. New type of plastic is being developed every day. So, it is sold under different trade names also, and they are used for bushing, steering wheels, tube for oils and water, automobile tires, etc. Every visible thing in this world are made up of somehow some amount of plastic. Plastics are divided roughly into 2 classes. They are thermoplastics and thermosetting plastics. So thermoplastics are the plastics which can be regained to their original shape and size after being melted. Okay. Upon heating, the thermoplastics will change to a new shape. When the heat is removed, that means if they are cooled, they will get back to their original shape and size. Whereas thermosetting plastics are the plastics which will be converting into a particular shape and they will not get back to their original shape upon heating and cooling respectively. And then we have ferrous metals and alloys. So particularly when we are discussing about metals, we have 2 categories. One is ferrous metals, which are the components containing high amounts of iron, whereas the other type is non-ferrous metals, which contains very low amounts of or negligible amount of iron. So the ferrous metals are iron-based metals which include all varieties of irons and steels. So with iron, we can form different alloys and we can form different steels also. Even steel is also an alloy for iron. So even while the iron ore is being filtered or it is being prepared, we will get different types of irons like pig iron, cast iron, wrought iron, mild steel, etc. So depending on each filtration process or each refining process, we will get different types of steels or iron. So the term iron or cast iron and steel is in reference to a metal in which the iron is the major element. So remember this, whenever we are talking about a element called iron, cast iron or steel, they mainly contain iron as key component. Along with iron, they will contain some other elements like manganese or lead, carbon, etc. So their composition is very less when compared to iron. So that is why the elements which are named as iron, cast iron and steel, they mainly contain high amounts of iron, that is ferrous. So these are called as ferrous metals. So the major element of this metal is ferrous. Do not refer to a specific metal or alloy, but are loosely used to indicate a general type of iron alloy. So whenever we take any iron which is related to ferrous family, so they might be of steel alloys or basic irons. So they might be of any type, but they has to contain maximum amount of iron. And then we have non-ferrous metals. So non-ferrous metals are the metals which does not contain iron as the key component. They might have a little traces of iron in them, but the major component of non-ferrous metals is not iron. They may contain other materials like aluminum, copper, manganese, lead, zinc, etc. But the major component is not iron. So iron will be present in any of them because they are all dig out of the earth's crust. They may contain some amount of iron in them, but they are negligible. When we have more amount of iron, they can be called as ferrous metals. Here we don't have any iron composition, which is not remarkable. They will contain a negligible amount of iron in them, so that they can be called as non-ferrous metals and their alloys. When we talk about non-metal elements, first of all we see the aluminum is the best replacement for iron. When we take iron, iron is very heavy for a particular load. If I want to carry a load of 100 kilograms, I have to use a iron bar which is of weighing about 1 kilogram. But if I want to use aluminum for the same load, that is 100 kilograms, the aluminum bar may weight about half kilogram. That means same weight, same load bearing capacity is there, but weight is not same. The weight of the self weight of the object that is made up of aluminum is very less when compared to iron. So whenever we want to make structures that are floating in the sky or in the open space, that means aeronautics and aerospace applications, we prefer aluminum as the key component of the metals, because aluminum has the same amount of strength when compared to iron, but it has less weight. And then the second type of non-ferrous metal is copper. So copper is a very good electrical conducting material. It is mostly used in the preparation of wires because it has a very good property called malleability, which will allow copper to be drawn into thin wires. We can see in electrical wiring, very thin wires of copper can be formed, but we cannot prepare iron wires of the same size of copper wires because copper has this ductility and a malleability property. So it can be drawn into very thin sheets and thin wires can be prepared. So that is why the copper is used as a electrical conducting material, and it also has some applications in other industries. And then the third non-ferrous metal is manganese. So manganese, as compared to copper and aluminum, manganese has very low applications, yet it has its own properties, where manganese is now combined with some other metals like silicon, forming a new kind of manganese alloys which are as strong as iron. We know manganese is not as strong as iron, but when it is combined with elements like silicon, it can show the same properties as iron. Okay. And then we'll see what are polymers and plastics. So when we discuss about non-metals, we go for different non-ferrous metals or non-metals like rubber, leather, asbestos, and polymers. So among all these, the polymers or plastics have wide applications in the engineering industry because these are made up of organic materials. Even though they are made up of organic materials, the particular style of polymer that is being developed by the organic compounds that are made up of plastics, these plastics are not so biodegradable. We know plastic is a very hazardous material when we do not dispose it properly. It may cause environmental pollution because it will not biodegrade even after many years while it is in the soil. Okay, it may obstruct the water or the rainwater going into the atmosphere, going into the earth's crust. So plastic should be properly, it should be reused, it should be recycled in a proper manner. Otherwise, if it is thrown out in the outer soil, it may stop or it may obstruct the water that is being entered into the earth's crust, which may lead to water scarcity, and this may cause damage to the earth's soil as well. So polymers are organic materials having carbon as the common element in their makeup. So when we take the polymers, the main component of polymer is carbon. So that is why all the polymers are combinedly called as organic materials. If any material contains more amount of carbon in them, they can be called as organic material. So organic materials are those which are derived directly from carbon and consist of carbon chemically combined with hydrogen. Mostly, this carbon is chemically composed with hydrogen to form different polymers. We all know, we have studied in this previous courses, we have studied this, that carbon, when it is combined with hydrogen, we can see the formation of different elements. Like we can see different examples are there. So chemically, the carbon is combined with hydrogen. We can see the formation of non-metallic elements like polymers. So the oxygen, other non-metallic substances invariably having a complex structure. So because of this complexity, the structure of the polymer is varied in different ways. We can use the same plastic for the preparation of a polythene bag. We can use the plastic for the preparation of a water pipe, which can be used to run water in domestic purpose. So both of them are made up of plastic, but the polymerization process is different. Depending on this, we can use the plastic for multiple applications. Even if we see any items in our day-to-day life, we can see plastic. Plastic is everywhere. And then the next definition is about ceramic material. So ceramic materials are the materials which are made up of compounds like metallic and non-metallic elements. The crude cooking utensils of early man were the first applications of materials now used in jet engines and atomic reactors also. So in most of the engines, we can see the ceramic materials are being used because these ceramic materials have very high temperature gradient. That is why they can withstand very high temperatures. Even in nuclear reactors also, the walls of the nuclear reactors are made up of these ceramic materials, which will withstand very high temperatures. We know in nuclear reactors, the temperatures may reach very high value. Even at this high value, we have to protect the environment or the surrounding people who are working around the nuclear reactor. They have to be protected. So these ceramic materials, they can insulate this amount of heat. Even the ceramic material is being used in small furnaces, whereas this furnace will melt the metal. So we can understand the melting point of almost all the metals are varying from different values, whereas iron takes about 1000 degrees and aluminum takes about 700 degrees. So depending on the melting point of the particular metal, we have to choose a particular furnace. So all these furnaces are made up of these ceramic materials. Why do we choose ceramic materials as the insulating material for the furnace? Because they will withstand high amount of temperature. They can take more temperatures when compared to metals. So that is why they are used in furnaces and nuclear reactors and jet engines as well. So depending on the type of function, they are divided into many types. There are abrasives are there where the ceramic materials are being used for abrasive materials, like they can be used in the process of grinding machines where the metal tools which are made up of metals, they can be grinded or they can be sharpened with the help of this grinding wheels. So they are alumina and carbon. So these are the two abrasive particles, for example. And then we have pure oxide ceramics. They are MgO, Al2O3 and SiO2. So these are the examples of pure oxide ceramics. And then we have fire clay products. So fire clay products are bricks, tiles and porcelain materials. Bricks and tiles are used for the construction of buildings, and porcelain materials are the plates which are used for eating. So these are the materials. They are also made up of this fire clay products. They also comes under this category of ceramics. And then we have inorganic glasses like window glasses and lead glasses. So the mirrors comes under this lead glass, and the window glasses are normal type of glasses through which we can see. So these are also comes under inorganic glasses, which are ceramics. And then we have cementing materials like Portland cement, lime, etc. These materials also comes under the category of ceramics. And then we have rocks, minerals, refractories. So different types of rocks are there, like granite stone, sandstone, etc. These also ceramics. And then we have minerals like quartz and calcite. These are some of the minerals which are used in engineering application. They also comes under the category of ceramics. And then we have refractories like silica bricks and magnesite. So these are the materials which are used as internal lining for nuclear reactors and furnaces. So these are also ceramics. And then based on the structural classification, there are four types of ceramics. They are like crystalline ceramics, non-crystalline ceramics, glass bonded ceramics, and cements. So these are the four different types of ceramics which are widely used in the engineering application and for the construction of buildings as well. And then the next type of non-metal is glass. So we all know glass is a very delicate object, but if required thickness is given, it can be used to withstand loads. And glass is the one non-metal which can be used to see through. We can actually see through a glass. So it is any substance or mixture of substances that has solidified from liquid state without crystallization. Observe this word. The definition of glass is stating that the crystallization is not formed while the liquid state of the glass is being converted into solid state. And glass may also be defined as a hard, brittle, transparent or translucent material. It is chiefly containing of silica combined with varying proportions of oxides of sodium, potassium, calcium and magnesia and other minerals. So these are the key components of any, we are going to see those key components or constituents of a glass in a short while. And then glass is an amorphous substance having a homogeneous texture. We know glass is a very homogeneous texture material. Because of its homogeneity, we can actually see through a glass. If the texture is not homogeneous, we may not see. We can see the formation of cracks. So that is why it has a very good homogeneous texture, because of which we can see through a glass and we can use glasses for ventilation. When the window glasses are made up of this glass, we can allow lighting from the solar lighting can be entering into the room. And let us see what are the key constituents of a glass. So any glass will contain silica as the key component. Silica. And the second one is sodium or potassium carbonate, which will increase the viscosity of the liquid glass material. And then third component is lime. This lime, when it is added to glass, it will increase the durability of the glass particularly. And then manganese dioxide. So manganese dioxide is a material which is added to give color to glass. And then we have cullet. So cullet is nothing but it is the old broken glasses which are powdered and they are added into the freshly made glass so that it will increase somehow. It is recycled and it has a functional purpose. It will increase the stability and strength of the glass being made. And then we have other coloring substances. To give a particular color to the glass, we will add other materials. And then we have cermet. So cermet is a combination of ceramic and metal. So cermet, the name itself indicates it is a combination of ceramic plus metal. So it is a combination of both. So all the good properties of ceramic and all the good properties of metal will be combinedly seen in the case of cermet. So it is a composite material consisting of ceramic and metallic materials. There are generally high temperature resistance because the ceramics has this good property of withstanding high temperatures, and it has very good hardness, which is a very important property of any metal. So these two good properties, high temperature resistance and good load bearing capacity, these two are combined and they are seen in the case of cermet. A cermet is ideally designed to have the combined optimal properties of a ceramic and metal. So these are also called as metal matrix composites. So because the metal and the ceramic are combined in this particular cermet, so it is also called as metal matrix composite, because we have metal as the matrix material and the fibers will be made up of ceramics. So that is how we will call this cermet as a very important engineering material, because it has the good properties of both ceramics and metal. And then we have composite materials. So all the composite materials are made up of more than one material when they are properly combined. Observe that alloys and composite materials are not same. Even though alloys is a combination of two different metals, and composite is also a combination of two different metals, we can observe a visible difference in the case of composite materials. Like composite materials, they are not combined structurally. They are combined in a manner like we can clearly see them. We can clearly see the combination under a microscope in the case of composite materials. So it is a combination of two or more materials having compositional variations and depicting properties distinctively different from those of the individual materials of the composite. So in composite materials, we will combine one or more than one element together to form a new element called composite, where it will show the properties when two separate materials show their individual properties. When they are combined, they will show a new property. So this is the best property or the best advantage of using a composite material. So the composite material is generally better than any of the individual components as regards their strength, heat resistance or stiffness. Just now we have seen the example of a composite material, that is ceramic, which is a metal matrix composite. So the metal matrix composite will contain both ceramic material as well as the metal material. So the good properties of those two, generally ceramic will not have that much of hardness or strength, does not have any structural rigidity, whereas the metal will not have high temperature resistant capacity. Even though it has a high melting point, after that it does not have the metal temperature bearing capacity. So metal and ceramic, both of them are combined to form a new metal, that is cermet. So this cermet has the good properties of those two things, that is temperature resistance and structural rigidity. Both of the properties can be seen in a composite material. And then composite includes the following types of their multi-phase metal alloys, ceramics and polymers. So all these three things comes under a composite material. And then we have smart materials. So these are also called as intelligent or responsive materials. These are designed that one or more of its properties can be significantly changed in a controlled manner, such as stress, moisture, light, temperature, etc. So the definition of smart materials will tell you that these are the materials which will respond to external factors like stress, moisture, light, temperature, etc. So when there is a change in any of these conditions, the smart material will react. It will show some signs of reaction. Like we can take the best example. We have a glass which is polar glass. We call it as polar glass. So when it is exposed to sunlight, it will be converted into dark color. When it is not exposed to sunlight, it will be visible, like it will be transparent. So this is the best example for smart material, which is used in the case of eyewear, where we can use sunglasses which are made up of this material. When we are inside, when we are indoor, these glasses will be transparent. We can see through, and when they are exposed to sunlight, they will be turning black shade, so that we can use them as sunglasses. So piezoelectric materials are the materials that produce voltage when stress is applied. So this is another example of a smart material. When piezoelectric materials are subjected to stress, they will send some voltage or they will send some current, so that with that we can understand how much of stress is being applied on the particular piezoelectric material or the base material on which this piezoelectric material is attached. Okay, so photochromic materials are there. Photochromic materials which changes color when responded to light. For example, light sensitive sunglasses are there. Photovoltaic materials are electronics which will convert light to electrical current. Okay, so these are some of the examples of smart materials. And then we have conductors. We have this broad classification of materials when we are studying the flow of electricity. So they are conductors, semiconductors and insulators. We know conductors are the materials which are defined as materials which have free valence electrons and they can allow electricity to flow through them. Okay, they have free valence electrons. When electricity is made to flow over them, these free valence electrons will carry the electricity throughout their length. Some examples of conductors are silver, copper, aluminum. And then semiconductors. When we see the definition of semiconductors, these are the materials, either non-metallic elements, which allow electrons to pass through them so that they conduct electricity in the same way as metal. For example, zirconium and gallium are the best semiconductors. When these semiconductors they are subjected to high temperature, they will act as conductors. When they are at room temperature, they will act as insulators. So that is the property of semiconductor. And coming to the third one, that is insulators. These are absolute no temperature. They have high temperature resistance and also the electrical resistance is very high. So these are defined as the materials which offer very large resistance to the flow of current. And for that reason, they are used to keep the current in its proper path along the conductor. So an insulator is a material which is used to insulate the electricity. When a copper wire is used to make the electricity to flow, we have to insulate this copper wire with an insulator like plastic in order to insulate, in order to avoid the electricity from the copper wire to flow out. If we touch a copper wire which is carrying electricity, we may get or we may experience shock. So in order to avoid this, we have to insulate these copper wires and live wires with the help of the insulating materials like plastic or wood. Sometimes wood is also best insulator of electricity. So depending on the electrical conductance capacity, so there are three types of materials: conductors, which has high conducting capacity, and then we have semiconductors, which has less conductance when compared to conductors, and when the temperature is high enough, they will conduct electricity. And then the third type is insulators. So insulators will not pass electricity through them. They will act as complete insulators so that no electricity will pass through them. So this is the basic definitions and terminology that are related to engineering materials. We'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.